I think that's Emily logging in. Her computer's getting a little stacky, though. Hi, Emily. Emily, are you trying to get your computer set up? I can tell that you're logged in, but I think the camera and the speaker are having trouble. There it is. There you are. Hi, Emily. All right. The only thing I'm waiting on, I'm sending emails now, Emily, and we're waiting on the other two to join. So just get comfy. Did you see the problems that I put up for you to practice?
I just saw them.
Okay, go ahead and start on them.
Yes, my book doesn't, the chapter 2 fell out of my book because it's, you know, all of our books are used.
Okay.
So,
all right. So start with chapter 3, and I'll tell you, I can send you maybe a picture of the chapter 2 questions, okay?
Okay, I might be able to find them. I don't think I threw them away.
Okay.
They should be in my room. But,
all right, so start on chapter 3 then. But that's what we're working on today. It's just those questions.
Okay, I did start them.
Okay.
Is the test going to be about as, I don't know, is it gonna cover all the type of questions you me? Is it gonna be that intense?
Well, I mean, it's over all of your old chapters, and I pretty much take your old tests and I use the same type of questions, but if it's math, I use different numbers, and if it's multiple choice, I scramble them so you don't necessarily know the answer is going to be C. But, you know, it's the same, it's based on your old tests.
Yeah, but like they're easier things to remember. Like the each chapter focuses on a certain thing. And then not like a lot of sort of sub themes. Like
if it wasn't important enough to make it on a test, it's not important enough to make it on a midterm. So go through your old tests. I pretty much use that to write my midterm. And that's, you know.
I'm not sure I'm allowed to see the tests on it, but
I have to go through and give you permission. I'm sorry. I'll go through it today and give you guys permission to do those. Okay? But any paper tests that you have, you already have, except for the one that I have right now that I'm going to give you guys on Thursday, and the one that you guys just took that you have to give me on Thursday. I'll grade and I'll give back to you. But that's it. I don't know where everybody else is, but they should be joining by 2 because we've, you know, that's when we normally start our class. We'll see.
Do you have all the answers for the problems you gave us, like, in front of you?
Which problems?
The problems you gave us on Edmodo for the overview. You have this in front of you?
Yep.
Okay, because I've done problems 34 through 82 on chapter 3.
Okay, well, I still would like to wait until everyone's here to start going over answers, though. So, hello. So we are only waiting on one more person, but we'll give her until 2 before we start. So I'd say, Emily, keep working on other problems. Jordan, have you been able to start chapter 2 and the practice problems on Edmodo?
No, ma'am. I did not get those until I just went to Edmodo.
Okay, start working on them now. So start with chapter 2 and going through those problems, and then work on chapter 3. And Emily Carr, I'm going to take a picture of chapter 2's review so that you can start working on chapter 2, Emily, okay?
Do you want me to bring the test to you Wednesday? Because I won't be there Thursday.
Yeah, that's right. So yes, please bring it on Wednesday. And James could have picked it up yesterday, but didn't think of it.
Oh, yeah, I forgot about that.
Yeah, I did too, so don't worry. So I'll just give it to me tomorrow, or if I'm not at church, give it to James, or just leave it if Joel.
Okay, if neither of you are there, I'll give it to Joel. I'm sure it'll get there some way.
If neither of us are there, just give it to Miss Pearson. She can give it to me on Thursday when I see her. Okay.
Okay, perfect.
It'll be fine.
So,
all right.
Yeah.
Emily, help me out. I don't have the question numbers. Which ones were you told to do?
Excuse me one sec.
Hey, fish tank.
Yeah, I just got. Well, I'm getting another one, but you know.
That looks very nice.
Thank you. I'm just. That's like the only part of my room that's clean, so that's why I'm moving it while I get my book.
All right. Emily, which questions are you supposed to do in chapter 2?
Ask Gordon to show you the bear.
Before, no, never mind. Number, it looks like 99, 100, and 101, and 3. So, 99.
Okay, so I'm starting on the back page. So I'm going to send you a picture of those right now, okay?
Okay.
You got to tell me if you can actually read it, because if not, I have to take another picture. All right, so 99, 100, something, 103, that's it?
Mm-hmm.
Okay. Were you able to read those, or?
Did you, like, email the pictures or something?
Oh, I guess I can. Hang on.
Into Mom?
Let me get my email. I texted them to your mom, I guess.
Oh.
All right, so hang on. I'm pulling up my email now.
Not good.
Okay. To the 6 R's. The 6 C-A-R-S or C-A-R-R-S. I don't remember now. Do you have 2 R's in your last name? Emily?
Yes.
Yes, you do? Okay, got it. Thank you. The 6 cars at
Gmail.com.
Gmail?
Mm-hmm.
There we go. Thanks.
No.
Chapter 2. Nope, nope, nope. Paperclip. There it is. Okay. Hang on, I have to retake the picture. There you go. All right, it's sent.
Okay.
Is that sending to email or Edmodo?
I'm sending that specifically to Emily's email because she doesn't have the chapter 2 in front of her because it fell out of her book. So I'd sent her the chapter 2 questions.
Okay.
Oh, sorry, that wasn't for you. I'm telling your mom that.
Oh yeah, I can read that very easily. That's a great picture.
Yay, thank you. There. Okay, so all right, so Emily I just got a hold of that, and she's gonna watch the part that she's missing later. But so we're gonna start the lesson without her, and she's gonna just catch up on the parts that she missed, and then she'll join us whenever she's able to get online, which may be in 15 minutes, it may be in 30 minutes. So we are gonna start our lesson so that we're done by 3. And she'll just have to catch up the first, 15 minutes or 30 minutes, depending on when she joins. So listen, essentially you guys all should be done with chapter 9. You've taken the test, and so that should be finished.
The easiest test ever.
I am really happy to hear that. That makes me happy. So the next big thing is the midterm. My plan for the midterm is that today we're going to practice, and Thursday we are going to practice, and then you will take the midterm whenever you're able before the next class, which will be on Tuesday. Does that make sense?
Yes. I won't be there Thursday, but yeah, I will be studying.
Okay, good. Here's what you need to study, Jordan, and Emily, remember I already talked to you about this. We are going to be essentially taking questions from our old tests and using those as questions on the midterm. Anytime you have a math problem, though, I will give you new math numbers. Like, I'm not going to use the same numbers in the problems, but it will be the same type of problem. All right? So that's what the basics of it are. If it was important enough to make it on a test, it's important enough to make it on a midterm. So that's where you want to focus your studies. For the section on Flynn, the lab safety section, what I'm going to do is post the video that I showed my class on lab safety. I'm going to post that in Edmodo so you guys can watch it. And that way you'll know how to answer those questions. So they're pretty self-explanatory. They're pretty easy questions. There's only 5 of them, but 5 out of 100 is important. So I want you to try your best on those after watching the video on lab safety. Then you should have a good enough chance to answer those right, okay? If you don't answer those right, we can talk about it later. But I think that with having watched the lab safety video, you guys would be perfectly equipped to answer those 5 questions. Other than that, you've had every single test the same as what I've had in my other class, so the midterm is, really it shouldn't be a surprise. I would suggest studying your tests. Go through and actually cover up the answers and try to retake the test, okay? If it was multiple choice on the test, it probably is going to be multiple choice again on the midterm. If it was a math problem, I will have made it into a multiple choice question on the midterm. So this thing is all Edmodo. There's no short answers. It's all either true, false, not modified true, false either, just regular true, false, or it's multiple choice because I want it to be where it's as soon as you're done, you know what your grade is, okay? Essentially, the good thing about this is it's good for you to have to prepare for a very large test. So to have that little bit of stress of This is it covers a lot of material. It covers everything you've learned. It makes sure that you review the old material, because in chemistry it always builds on itself. You can't forget anything, okay? So that's the whole idea of why we're doing this. Any questions so far about that or about what I've told you?
No.
All right. So besides answering the questions in the book that I gave you, also study your tests, and that should be enough to prep you for your exam. On Thursday, like I said, I'm going to give you back your test from the last chapter. Jordan, what I'll do is I'll bring that on Wednesday to church so I can give that to you. And then what I'm going to try to do is grade your new test, the one that you took. I'm going to try to grade that for you guys before I leave on Thursday, and for you, Jordan, on Wednesday, so that you can actually study from that test as well. All right? Okay. So next Tuesday, we are starting new material into Chapter 10, and you will have been finished with your exam. Everyone on the same page about that too?
Sorry, what?
So by next Tuesday, you will be done with your exam, and we're starting Chapter 10.
Okay.
Okay.
So we get a report card before or after?
What?
Do we get a report card before or after?
After, because the midterm is on your report card. So what I'm going to do is actually print out a complete report card from all of the stuff that we've done. All of your quizzes will be on there, all of your tests, and your midterm. And it will show you each category's grade, and then it will show you a final grade.
Cool.
Okay, we don't have to panic yet.
My goal is that when you come in on Tuesday, I can hand you that report card. All right?
All right, and my goal is to get that in before my mom sees it, because I'm probably not going to like the numbers on there.
I'm going to hand it to your mom then.
Oh.
She will be getting the report card. That's why they are made, is so you guys can see how you're doing. All right. With that being said, now we can go ahead and start. I think that covered thoroughly all my expectations. We're going to start on Chapter 2 review. And essentially what I was going to have the next 2 days be is, if you guys are getting the material and you understand it, we're not going to waste time on it. We're just going to keep going. But if you need work, we can also go back and reteach the areas that you need retaught. So I'm starting in Chapter 2. You guys tell me again, I don't have the question numbers in front of me. You may have them in front of you. So help me out with telling me what was the first question that we were supposed to do in mixed review in Chapter 2. Number 99?
Yes.
All right, so number 99 is where we're starting. And I think I didn't give you every letter. I gave you specific letters, didn't I? Or did I give you every letter?
A, B.
I'm looking right now.
A, B, and actually, you know what? I'm going to just pull it up. I'll be too annoyed doing this and not actually seeing what the questions are. So let me just find it. Lesson plan. All right. Let's back this up.
I have not done Chapter 2 yet. I'm working on Chapter 1. I'm not okay.
All right, I've got them. All right, number 99, A, B, and C. So let's start with A. And this one is asking you to complete the following problems in scientific notation, round to the correct number of significant figures. This is really important because we do use significant figures and scientific notation the entire year. So let's start with the first one. 5.31 times 10 to the negative 2 centimeters times 2.46 times 10 to the 5th centimeters. All right, so what is the rule when we are multiplying with scientific notation? Come on, guys.
Okay, I just brought up, I hadn't done this problem yet. I was trying to catch up. What's the rule in scientific notation? What do you mean?
Yes. Remember, when we're multiplying, dividing, and we're adding and subtracting, we do different things. So with adding and subtracting and multiplying and dividing, there are different rules, all right? So adding and subtracting, multiplying and dividing. When you add and subtract, what must be the same?
Adding is whether, no. adding and subtracting. Does this
Write this down, guys.
have anything to do with significant figures yet?
Not yet. All right, so ready? The exponents must be the same.
The exponents, the little -2 and things like that.
That's when adding and subtracting. Now, when multiplying and dividing, all right, so hang on, let me rewrite these rules so you remember. So this is the reteaching part. So when adding and subtracting, the exponents must be the same, and then you just add and subtract like normal.
Right.
And the exponent stays the same.
Okay. When.
All right, so here it is. When adding and subtracting, the exponents must be the same, but then you get to add and subtract like normal, and then the exponents stay the same. When you are trying to change the exponent, remember that if we go to the left, we do what?
Left.
When we move the decimal to the left, we must what the exponent?
Increase.
Increase. When we move to the right, we must?
Decrease.
Decrease. Good. So if we go to the left, we increase our exponent. When we go to the right, we decrease our exponent. So that's the rules that we learned in chapter 2. Now let's talk about the rules for multiplying and dividing. Do you have to have the same exponent when you multiply and divide?
No.
Good. So you do not need the same exponent. That's only adding and subtracting. So since you do not need the same exponent when you're multiplying and dividing, all you do is you multiply if you are multiplying, or you divide if you're dividing. So hang on. Multiply the coefficients or divide. And then when you're multiplying, what do you do with your exponents?
Add or subtract.
Add the exponents. And then when you're dividing, divide the coefficients and subtract the exponents. That's it.
The coefficients, you mean the big long string of numbers, the main part of the problem?
All right, let's talk about identifying terms. 5.31 times 10 to the -2. Which part of this number is the coefficient? Is it the 5.31 or is it the -5?
The 5.31?
Yes. 5.31 is your coefficient. This is my exponent.
Okay. And you, when multiplying, you add and subtract the exponents?
Yes. When multiplying, you add. When dividing, you subtract. Notice how the symbols are similar? Look, multiply, and then you add. You just turn the multiplying on its side. Multiply, add.
Mm-hmm.
Divide.
When you're multiplying, you add the coefficients, and they don't have to be the same.
Correct. And when you're dividing, you just subtract the exponents, and they don't have to be the same. Okay? Notice how the symbol looks similar because it's just this is the divide sign without the dots. So they go together. All right? So far, so good?
Mm-hmm.
Okay, so now let's put this to practical use. Look at the example again. I have to get an eraser. I didn't actually get an eraser before, so hang on for a second.
0.31 times 10 -2 times.
All right, so the first one says 5.31 times 10 to the -2. And then it doesn't matter that it's centimeters, so I'm going to leave that off to save space. Times 2.46 times 10 to the 5. Now, remind me, which rule are we going to apply here?
Adding and subtracting exponents.
All right, so since we're multiplying, we're going to use the multiplying rule. So that means, what do we do with our coefficients?
We just multiply.
Good, so take 5.31 and multiply it by 2.46, and what do you get?
You get 13.826. I don't remember how to multiply. I haven't done it since 4th grade, practically.
13.0656. That's what I got. All right, now what do we do with our exponents?
You add them.
We add them. So look, type in your calculator, -2 plus 5.
3.
Hang on, this is Emily. Hello. No, what? Sorry. Hi, I know it's Emily. What's up? We have started already, but go ahead and join us now. And that's fine. And you'll only have to make up a little bit of the video instead of the entire thing. Oh, got it. Yeah, that's perfectly fine. So go ahead and just watch it on YouTube and, you know, work through the problems with us. And, you know, that'll be it. It's fine. I hope that you're doing all right. All right. Bye. Okay, so Emily's not going to be able to join us, guys. She'll just watch this whole video later. So I ended up with 13.0656 times 10 to the 3, right?
Right.
Now, can't finish this answer like this. What do you have to do now that you're done with the actual math? What are the other rules that we have to look at?
The decimal place must be at the ones, like after the ones.
All right, hang on. We've got some more rules. Let me write them down really quick and then I'll show you. Times. All right, so with adding and subtracting, hang on, I need to switch out markers. Adding and subtracting, the rule is that you have to have the same decimal place as the least accurate. So adding and subtracting the same decimal place as least accurate, right? You guys got that written down and reminding yourselves? Multiplying and dividing, there's a different rule. Sig figs are different when multiplying and dividing and adding and subtracting. When multiplying and dividing, your sig figs need to be the same number as the least.
You expect us to remember this?
Oh yeah, because we are going to use it all year.
Huh.
Multiplying and dividing the same number as the least sig figs. So now look, which rule are we going to use? Adding and subtracting or multiplying and dividing?
Multiplying and dividing.
Because we are multiplying. See? So we're going to use multiplying and dividing rule. So count for me significant figures. Ready? Remember our 3 rules? First rule, all non-zeros are significant. Second rule, a 0 that's Oreoed or sandwiched between 2 non-zeros is significant. Third rule, if there is a decimal, find the first non-zero, reading from left to right, and that number and everything after it gets to be significant. Make sense?
Yes.
So look here, 5.31. What rule would apply? Rule 1, 2, or 3?
1.
Rule 3 is the trump card. Remember, the trump card always wins. If there's a decimal, is there a decimal?
Yes.
That means it always wins. If there is a decimal, you always use rule 3.
Okay.
So rule 3, if there's a decimal, first non-zero, right here, everything after it gets to be significant. So how many numbers?
3.
3. Do not count this. This does not, the exponent does not count towards your sig figs, just the coefficient. Okay? So 3 sig figs here. Now look at this number. 2.46. Which rule applies?
That'd be
3 again.
Rule 3 again, because there's a decimal. If there's a decimal, it's always going to be the decimal rule. So find the first non-zero, which is?
2.
Right here, the 2. So everything after the 2 gets to be significant. That's 1, 2, 3. 3 sig figs. So our rule with multiplying and dividing is that our final answer must have the same number of sig figs as the least. All right, so which one is the least? Well, they're the same, so we need 3 sig figs in the final. Right now we have 1, 2, 3, 4, 5, 6. How do we make that only be 3?
By rounding 0 up to 1 and canceling everything from 6 on.
Good. So we're going to stop here at this digit, right? And so we have to look after it. If it's a 5 or higher, you round up. And if it's a 4 or lower, you round down. So, or stay the same. So we're going to cut this off and we're going to go, since that was a 6, it's now going to be a 1. All right. Now, is this answer finished?
Nope. This one has to be moved.
Good job. This is not finished yet. You have to still put this in correct scientific notation. So now we have correct sig figs, but we do not have correct scientific notation because how many numbers are allowed to be to the left of the decimal place, or how many digits do you want? Only one number, only the one's place.
To the left. Well,
we have to move to the left.
Right from the screen.
What?
Technically, it's your right, but you know.
Oh, sorry. Yeah. I don't know how well it looks on your guys's. It always looks like my numbers are backwards when I look at them on the
That's what I was looking at. It was like, that's not what I got.
Sorry. So when you move this over to the left, you're going to end up with 1.31 times 10. And what happened to our 3? Do we increase it or decrease it?
Increase.
We increase it because we went to the left. So when you go to the left, you increase it to a 4.
Because you're decreasing the coefficient.
I'm trying to get there we go. It shows me. Good. So does that make sense?
Yes.
All right. Now you guys, because some of you may already have this done, we're going to do the next one. And I want you to tell me how to talk through this one. Okay. So let me write it down. So it's 99B. 3.87 times 10 to the 3. Actually, these are all multiplication. Can we do a division one? I'm gonna throw a monkey wrench in there, and we're gonna try division, so that you guys can practice that as well. Let's do D randomly. All right, so 9.33 times 10 to the 4th, and we are gonna divide that by 3.0 times 10 to the 2. Talk me through it.
All right, so you would divide 9.33 by 3.0.
Good. So start with that and tell me what you get.
Can you hold it up there so I can write it? 3.11. Well, 3.11.
All right. 9.33 divided by 3. Yes, 3.11 is what I got as well.
And then you would subtract the coefficient. Not the coefficients, the exponents.
Yes, and so then you subtract the exponents. So you go 4 minus 2. And what does that do?
So it would be 3.11 times 10 to the 2nd power, or 10 squared.
Good. Now, is this incorrect scientific notation?
Yes.
Yes.
Yes. Does it have the correct number of significant figures?
No.
Good. Why not?
Because 3.0 only has 2 significant figures.
Good. Notice that you have to, when you're multiplying and dividing, you have to go with the lowest number of sig figs. And this number has how many?
3.
And this number has how many?
2.
2. So we need 2 in our final answer. So what is our final answer going to be?
3.1.
1 times 10 to the 2nd power.
3.1 times 10 to the 2nd power. Any questions? All right, look, I don't know if you guys are good on this, we're going to go on. Do you feel like this is okay?
Yeah, sure.
Okay.
Okay, so now I'd like to go on to, let's see, the next problem I had you practice was 100, and let's see, that was A, B, and F. All right, good. So this is converting in the metric scale. Because remember, we learned a mnemonic device to help us remember how to convert in the metric scale. What was that mnemonic device?
King Henry died by eating chocolate. No.
By not eating.
Drinking.
Drinking chocolate milk. King Henry died by drinking chocolate milk. This is kilo, hecto.
Oh, man, I remember that.
Yes, we do. We have to remember this. All right, let me go in order. Hang on. Kilo, hecto, deca, base, which is like just the normal like centi.
Gram.
If you have centimeters, the base is meters. So this is the base, whatever unit you're dealing with. Then you have deci, centi, milli. All right. So we start with 3.01 grams, and we are converting that into centigrams. Where do we start on our scale?
Base.
Because we have grams, we are here at the base. Where are we going?
3 places down.
Good. We're going now. Is that really 3 places? We're going to go 1, 2, and we're at the place that we need, right?
Yes.
So we shift our decimal the same number of places, the same direction. So how many places do we go?
3 places.
Look, you start at the base. Don't count that. Ready?
Oh,
1,
2. Sorry, I was counting the base.
Yeah, don't count the base. That's where you start. Just count the ones, like count this and count this.
I thought you were going to milli.
301 centigrams, is that what it was?
Yes, it's 301 centigrams. What did you say, Emily?
So we're converting from grams to centigrams?
Yes.
Okay, that's...
And so that would be 301 centigrams.
Uh-huh.
Does that make sense?
Yeah, sure.
All right. Well, you guys prove it. Let's see. B, 6,200 meters is how many kilometers?
600 what?
6,200 meters.
Right, so that's going to
All right, I'll talk. You guys got
be kilometers. Well, kilometer. I don't know how you say it.
kilometers is right. The prefix is kilo, but it's kilometers when you say it together. In order to keep me as the big screen for you guys, I have to keep making noise. Does that happen with your screen as well? When like Anne pop or when I just called your sister's name. Sorry. When Emily pops up in the main screen, do you guys see Emily's face bigger or not?
Yeah, I see her face when you're not talking. For some reason, it's doing that. It was starting with you just being on the front, but now it's just switching. I don't know why.
Yeah, I keep having that happen too, and I wonder if I can lock it because it's really hard to keep.
Yeah, you should be able to. If it says that you're the host of the Google Hangout, then it should allow you to lock your screen.
Yeah.
Or have where ours comes up only when we talk.
Well, it is coming up only when you talk. It's just I don't want it to come up even then. I'd like to have it just be my screen so that I can just hold this up here and have you answer the question and not have to be talking for you to still see the numbers. So what is the final answer, though, by the way?
0.0006200.
Because we start at the base, because we are at meters, so that's the base. And we're going which way?
Left.
Good. So we're going to go left how many places?
3.
1, 2, 3. 3 places. And so we need to take our decimal and go 1, 2, 3, and we're going to end it with 6.200. Actually, wait, that's wrong.
Yeah, you went in the wrong direction.
No, I went the right way. Sig figs. Don't include the zeros if they're not significant in the original number. There was no decimal written, so this only has 2 significant figures because watch.
What?
With it 6200.
I thought we were working on converting from like meters to kilograms. What does that have to do with significant figures?
First off, we're going from meters to kilometers, not kilograms. So we're in the same unit. And sig figs still apply. Remember, they apply for everything. We use them all year. So this number has how many significant figures?
2.
So our final should only have 2 sig figs. So this is 6.2 kilometers. Does that make sense?
Yes.
Sure.
Because you would get rid of the zeros.
Yeah. You're just showing how accurate your measurement was. That's what significant figures do, is they show how accurate your measurement was. All right, we are going to try to speed up a little bit. 101 asks you to find density. All right, so this is good. Notice how they give you the mass of a sample, the volume of water, and the volume of the sample and the water at the same time. How do you find the volume of just the sample on its own? You should be looking at page 64, number 101.
What was the question? Density.
All right. Emily, I'll come back to that in a second. I'm going to re-ask it in just a second. I realized I jumped the gun. First, how do we find density? What's our equation?
Density equals mass over volume.
Good. Density equals mass over volume. Density
That was that iHeart.
Remember? Love? So we need two things to solve for density. We need mass, we need volume. Notice that they gave you a table, right? Everyone looking at it? And you're looking at it, Emily, in the picture?
Yep.
Okay. They gave us the mass. They gave us 2 volumes. How do you find out the volume of just the sample?
It's 3 milliliters.
How did you find that?
Because it's very obvious.
I know it's very obvious to me, but it's not going to help someone if they don't have that be very obvious to them.
From the sample and not the water. You take water from the water plus sample.
There you go. So I actually think that we've done a lab like this, but I don't remember if we did it in my class with you or if I did this with my other students. So essentially what you have when you use a graduated cylinder is you have a long skinny cylinder and you put water in it and you measure the volume of the water. And then you drop whatever it is that you want to test, you drop it in there and the water changes, it rises. Right? So to find how much the volume of this sample was, you take the volume that was starting out with, your initial volume, and you take your final volume and you have to subtract the 2. That's why Emily said 3 and she's right. Okay, because you're just subtracting the initial minus the final. And in this case, they call it the volume of the water and the volume of the water plus the sample. Does that make sense? So this problem becomes, what's the mass again?
Mass equals, density equals mass over volume, and we have volume. So 12 equals.
All right, so look at your table. What was the mass that they gave us, Jordan? Mass of the sample. It's right there in the table, 2.6. Not a trick question.
The mass of the sample is 20.46 grams.
20.46 grams. What's the volume of the sample?
3.0 milliliters.
Oh, I'm sorry. I didn't put the M. So we divide. So tell me what this is when you divide.
You gotta snap your fingers. It went down. Okay, there we go. Thank you.
All right, don't talk anymore. Just looking. There we go. So as long as nobody makes any noise, we are good. Oh no!
I got 6.8 on mine.
All right, I still have to type it in and see what I get. All right, so I got 6.82 as well. What is the number of sig figs that we want in this answer?
1, but 2. Sorry.
2. Good, because look, this one has how many? This one has 4. This one has 2.
But it's rule number 1 that comes in. Verse 0. Which one was it?
Decimal rules for both of them. They both have decimals.
That's what I was thinking of.
All right, so this should have 2 sig figs. It should be 6.8 grams per milliliter. Notice you have grams per milliliter because your units don't cancel. So we have grams over milliliter. All right, any questions over density and how to find density? It'd be very good to know how to find density. Same thing with adding, subtracting, multiplying, and dividing with scientific notation and sig figs. Those are definitely on your test.
Okay.
All right. Same thing with converting your units. All right, let's see. 103 says you have a 23 gram sample. Oh, this is asking for, okay, so they give you a density and they give you a mass. Wow. My markers are dying, guys. Sorry. How would you set this up? Number 103 says you have a 23 gram sample of ethanol with a density of 0.7893 grams per milliliter. What volume do you have? Come on, guys. Work it on your own.
Thank you.
So essentially you set it up like this. Density equals mass over volume, right? And so this equals 0.7893 grams per milliliters over 23x. Here's what I would do. Take your density, grams per milliliters, and split it apart. Grams per milliliter can be rewritten as grams over 1 milliliter. Right? Okay. Now, you can just cross multiply and divide. You guys know how to cross multiply and divide?
Yes.
Okay, so I'm going to leave this up here and you guys can cross multiply and divide. So when we cross multiply, we're going to have the top.
23 grams per milliliter?
So we're going to have the top times the bottom, so it's going to be 0.7893 grams x.
The answer is 29, right? 29 milliliters.
Not there yet. So now you have that. Remember, that's when you cross multiply. You multiply your top and your bottom of both fractions. Okay, do you see that so far? And then you divide, get x on its own. So divide both sides by the 0.7893 grams. I'm running out of space. So grams will cancel, and so you're going to end up with
29.1397 something.
893. Yep, 29.1397. How many significant figures do you want on your final answer?
2.
How many? Yes, 2. So we're going to end up with just 29 milliliters.
Okay, the first time I did that, it was 30. I must have done something wrong. Yeah.
You had too many questions at once. Sorry, start with Emily and then start with you. What?
Why do you cross multiply? It's exactly the same as dividing, only more difficult.
No, because if you have, instead of having your volume be missing, what if you had your mass be missing?
If you had mass,
all right,
then you would multiply.
All right. Essentially, if you cross multiply and divide, you will always get it right. Always. And I've had many a student that didn't do that, that did a different method, that thought that they could do it that way, and they mess it up. So I teach the method that will always get you to the right answer. If you have a different method that will work, I'm okay with that. Listen, it's algebra. There's millions of ways to solve this, okay? So if you have a different method, Emily, that you prefer, go ahead and do that. I'm not going to debate you on it. It's just going to be something you can do that's different, okay? But when I teach you, I'm going to teach you the method that I use because I know it always works and kids don't get confused. So there is a way to just either multiply or divide in the first step if you know how the math works, and that's fine.
Yeah. I mean, to me, multiplying is exactly the same as cross multiply. I mean, cross multiply.
It's not in every situation, but there is, there's times when it'll work and times when it won't if you're doing it the way I think you're doing it. But I don't have time to sit through and look at exactly the way you're doing it. If you want to show me on Thursday, that's fine. But I know that there are some situations where, yes, a method like what you're saying will work, but there's other situations where it won't. So that's why I always set it up the same way every single time.
Okay.
All right, Jordan, what was your question? I didn't hear yours. Also, I don't see you. Did you run away?
I had to grab my charger because my computer was about to die.
All right. Well, I'm glad you're back and that your charger is now going to keep your computer from dying. What was your question?
What you just said answered it for me.
Okay. All right, so here's what I'd like to do before leaving chapter 2. I realized that we didn't get a practice problem where we were adding or subtracting with scientific notation, so I'm going to give you another one of those randomly, and then we will go on. So let's go ahead and take 8.39 times 10 to the negative 5 minus 2.4 times 10 to the negative 6. All right, remember our rules when we are adding, subtracting, and multiplying and dividing. What's the rule with adding and subtracting?
With subtracting, you subtract your exponents. So in this case, it would be negative 5 plus 6.
Nope. Jordan, when you are multiplying, you add the coefficients. When you are dividing, you subtract. That's the only time that you add and subtract your coefficients or exponents.
The coefficients have to be the same right now.
The rule is when you're adding and subtracting that your coefficients have to be the same.
Oh, right.
All right. So how do we turn these two coefficients and make them the same? Or sorry, exponents. We have negative 5 and we have negative 6.
Make negative 6 to negative 5 by moving the decimal point on the bottom to in front of 2.
Good. So remember, we want to, with negative numbers, less negative is actually to increase, all right? So to increase our negative 6, we have to move the decimal left. So remember that that's why we reminded you of that when we started. So here we go. We shifted our decimal. Now I'm going to rewrite this number, all right? So I'm going to rewrite 0.24 so that it lines up with my number up here because it's a lot easier when they line up. So we're going to line it up 0.24. Good?
Sure.
Now what? Now that you have your exponents the same, you're allowed to do what?
You just subtract like normal and keep the exponents the same. Nothing changes.
That's it. You just subtract like normal and keep the exponents the same, and that's it. So we're going to take 8.39 minus 0.24. And then we're going to leave the 10 to the negative 5.
8.15 times 10 to the negative 5.
All right, now let's talk about significant figures. Remember, when multiplying and dividing, you had to have the lowest number. When adding and subtracting, it's the least accurate decimal place. And you can only do that when the exponents are the same. Now that the exponents are the same, how many decimal places did this one have?
2. They both have 2.
How many did this one have? So we're allowed to have how many in our final?
2.
We can have 2. And so this is fine, the way it's written. All right, does that make sense?
Yes.
Yes.
All right. Would you like to do one more like this or go on to chapter 3?
Sure, we can go on.
Okay, Emily, what's your vote?
Sure.
Go on. All right, so let's go ahead and go to chapter 3, which was on page 94. All right. We're going to start with number 34. Identify each physical property as either intensive or extensive or intensive. All right, so tell me the difference between an intensive and an extensive physical property.
An extensive property, you can only determine it by it's based on like how much of the substance you have. Intensive doesn't change no matter how. It doesn't matter how much you have of it. It doesn't change.
That's right. All right. So first off, the important distinction is it's definitely a physical change and not a chemical change. And then when you're looking at it, it's going to be either dependent on amount or not dependent on amount. So if we take something and we are melting it, all right,
Mhm.
If it's melting, it's a physical property because it's not changing the chemical makeup of it. So if we have an ice cream cone and it's melting, and then we have an entire gallon of ice cream and it's melting, will they melt at the same temperature or at different temperatures?
Same.
Temperature.
Same temperature. So melting point is an intensive property. It does not change whether you have a little bit of ice cream or a bunch of ice cream. That's what makes it intensive. But now let's talk about the same ice cream and talk about if we measure its mass. How heavy is it? Would it matter then if you have one ice cream or if you have a gallon?
Yeah.
Yes.
Yes. See how they're different?
Yes.
Okay, so let's look at it. Oh, I covered ones that they covered in the question. I didn't mean to do that. Melting point would be?
Melting point would be intensive.
Intensive. Mass would be?
Extensive.
Extensive. Density would be?
Intensive.
Intensive is correct because density is mass over volume, and that ratio is always the same no matter how big or small the sample is. Length.
Extensive.
Length is extensive as well because if you have a marker that's this long, it's going to be, a certain length, but if we cut it in half, obviously it's going to be a shorter length.
Mhm.
All right, number 38. Classify each as either chemical or physical properties. So I'm going to read it and you guys are going to say what you think. Aluminum has a silvery color.
Physical.
Yes,
Physical.
Color is physical. Remember, try to think of if you're ending with a new thing or if it's an irreversible process, that's a good indicator that it's a chemical property and not a physical property, okay? Gold has a density of 19 grams per centimeters cubed. What?
Physical.
Physical is correct. Density is always a physical property. Just remember we talked about whether it's intensive or extensive before as well. Those are physical properties. All right. Sodium ignites when dropped in water.
Chemical.
Chemical, because burning is a chemical change. Water boils at 100 degrees Celsius.
Physical.
Physical.
It is physical because anytime you have a phase change, like melting, boiling, vaporization, those are all physical changes.
Excuse me one moment. My dad's calling me. I got to answer him.
Go ahead.
Hello?
Well, he's doing that, Emily. You don't answer these next, but I'll have you answer them now, and then when he gets back, he can answer them. Silver tarnishing.
What? Chemical.
Silver tarnishing.
Chemical.
Yes. Mercury is a liquid at room temperature.
Physical.
Yes. All right, so you got that. What's next?
58.
All right, thank you. 58 says, describe a method that could be used to separate each mixture. So iron filings and sand.
Crystallization.
For this one, it's not actually one of the 5 techniques. I don't like that question very much. Iron is attracted to a what?
Oh, to a. Do you mean magnet or?
Yeah, so they were saying you could separate with a magnet, but that's not one of the 5 techniques, so I don't like that question. This one's better. Sand and salt.
Distillation.
Good. You could actually put them both in water and boil the water. You could also put them both in water and do what before you distill it? You get the sand and the salt water to separate. Put it through a.
So,
What would catch the sand but allow salt water because the salt is dissolved to pass through?
oh, do you mean a filter?
Yes. Put it through a filter. So if you put it through a
I
filter.
hadn't thought of dissolving the salt.
Yeah. So if you put water with the salt and the sand, the salt would dissolve. In order to do what you had said, which was distillation, you actually have to have added water. There's no way to distill it if there's no water. So I thought that you were on the same page. So my suggestion would have been to use a filter first to catch all the sand. So see, if you set it through a filter, all the sand will stay up here, and then down in a container you'd get your salt water, and then you can take that salt water and put it through a distillation, and you can separate the water from the salt. All right, so now the composition of ink. How do you separate that?
Chromatography.
Chromatography is correct. Good. And then helium and oxygen gas.
Sublimation. Sublimize. How do you say that?
Sublimation.
Sublimation.
Sublimation is
Sorry
correct.
about that.
No, you're fine. So you would cool them until one of them turns into a solid. That's great. Okay, Jordan. So quickly, silver tarnishing was a what?
Silver tarnishing is a chemical reaction.
Good. Mercury is a liquid at room temperature.
Physical.
Good. Then what we did next was the separation techniques. So number 58, iron filings and sand. How would you separate that? That's a bad question because it's not one of the 5 techniques we talked about. But essentially, what could you do?
That would be. Ask that again. I'm sorry. It lagged through.
Okay, that's fine. If you're trying to separate iron filings from sand, what could you use to separate that?
Filtration.
I'll take it, but the method that they were talking about wasn't one of the 5. It was just use a magnet because iron would be attracted to the magnet. Sand and salt. How do you separate a sand and salt mixture?
Oh, that would be distillation because the salt will dissolve in the water.
Salt will dissolve in the water. I'm going to make this a 2-step one, just like with Emily. First, I would take and I would put water in the sand and salt. So you're right. Dissolve the salt into the water. Then I would take my salt water and I would take and pour it through a funnel. Because through the funnel, you can
the salt and water will keep going and the sand will stay.
Good. So you put that through there. The sand would stay, and all of you in the bottom, you would end up with just salt water, right? Then take this salt water and put it through a distillation machine. And so you could take and distill it down with fire, and the salt would stay here and the water would separate. So, yes, both of those would work. And then the composition of ink.
Composition of ink, that would be physical.
Which of the 5 methods would you use to separate it?
Oh, sorry. I was thinking color. Sorry. Separating the color of the ink. So.
We made very pretty things with our.
Oh, I remember that. I know what it was. I'm just trying to remember the name. Shoot, what was it?
Chroma.
Oh man, you're gonna just have to tell me. I can't remember it.
Chromatography.
Chromatography. Okay.
All right, and then how do you separate helium and oxygen gas?
Filtration, crystallization. I need to look back over these. All
right, so you could cool them down until one of them crystallizes out or deposits and becomes a solid.
Crystallization.
So, yes. Another thing you could do is cool them until they become a liquid and then distill them afterwards. So there's a couple options there. All right, now we're going to go on to 81. All right, 81. Which states of matter are compressible?
I looked this up. This is how I know it. But solids and liquids are incompressible because they are dense, but gas is easily compressed.
There you go. So gases. Which state of matter is? Oh, you answered both. Never mind. All right. So solids and liquids are non-compressible, and gases are compressible. Next, we had number 82. Classify each as homogeneous or heterogeneous. So what we're going to do is go back and forth, and you're going to read the letter and then tell me what you think. So Jordan, go ahead and read A, and then Emily, you'll do B.
Shoot.
Brass, an alloy of zinc and copper.
That'd be heterogeneous.
All right, so let's think of the differences between homogeneous and heterogeneous. Remember what those prefixes mean. Homo means?
One.
It's smooth.
Well, same.
Same. Think of like other times you see that used. Same, right? Yeah. Hetero, what does that mean?
Different.
Different. So you can see different pieces. So when you have a mixture that's a homogeneous mixture, you cannot see pieces. It's the same composition throughout. It's uniformly spread out. If you have a heterogeneous mixture, you can see distinct pieces. All right? So think about it. Brass. If you have an alloy where 2 metals have been melted and joined together, Can you see distinct pieces of each metal?
No.
So what kind of metal is it?
It would be heterogeneous. Homogeneous.
There you go. Homogeneous is correct. All right. Emily, go ahead and do the next one.
I don't remember what it was, but it was a salad, and I say it's heterogeneous.
Yeah, because you can see different pieces in the salad. Blood. Jordan, what is that?
That'd be iron.
There's like red blood cells, white blood cells, plasma.
That'd be heterogeneous.
Yes, that is heterogeneous. Good.
Well, you could classify it as homogeneous because they're all cells, but yeah.
No, because you can see distinct pieces. If you leave a sample of blood, it'll settle out, and you'll have the plasma, and you'll have the red blood cells, and you'll have white blood cells, and they're not the same. They'll actually make distinct layers.
Oh, okay. Never mind. Sorry.
It's fine. How to drink dissolved in water?
I did heterogeneous because whenever you dissolve, it doesn't dissolve completely, and you can see it.
Okay,
but
so
if it was genuinely dissolved, I guess in theory it would be homogeneous, though.
It's supposed to be homogeneous, and the reason is you're not making a super or an oversaturated solution, which what you're describing is when you make an oversaturated solution and there's too much powder in there and it can't actually all dissolve. They're talking about a real actual even mixture where you have it completely dissolved. Another example would be like if you have salt water, you can't see any salt anymore because it's dissolved in the water. And same thing like sugar water, it's dissolved in the water, so you can't see it. When something's dissolved, that's usually an indicator, that's a good word. That means homogeneous because you can't see it because it's dissolved. Questions?
No.
Okay, so let's go on to number 87 and the last question in this section. Cooking. List physical properties of eggs before and after they are cooked. Based on your observations, does physical change or a chemical change occur when eggs are cooked? Justify your answer. So I want each of you to answer independently. So we'll start with Emily.
When eggs are raw, they have a more liquidy texture, and the whites are actually pretty clear. After they're cooked, they take on a much more solid feel, and the whites are actually white. Yolks also tend to change color a little, and the smell changes.
All right, pause. I'm not going to let you answer the final part of it yet. So okay. Jordan, you tell me your observations, any other ones that she missed?
Not really. I mean, I'm going to have to review this a lot because it's been a while. But
it has been a while, which is why we're starting with the oldest chapters to help you see if you need to study those. Because the oldest chapters are the ones you're most likely to have forgotten. Right? All right. So Emily, you were correct. You listed all of the, a number of physical and observations before and after they were cooked. So now infer. And I'm going to make Jordan do this because you have to think through what she said and prove to me that you actually listened to her. So Jordan, based on the changes in the observations of the color and the texture and the smell, what do you think this is? Physical or chemical change?
I would think this is physical.
Okay, Emily, what do you think?
Chemical.
Why?
Because one thing you cannot undo, you cannot make a cooked egg raw. Also, because color has changed, smell, and consistency.
Good. So some obvious evidences of a chemical reaction are color changes, smell changes, production of a gas, production of a solid that wasn't there, texture change. Also, a good rule of thumb is if it's irreversible, it is a chemical change. You cannot, like you said, you cannot take a cooked egg and make it be raw again. Right? Think about paper. If I take a piece of paper and I burn it, can I unburn that paper? No. No. So that means it was a chemical change. It says changed. You can't reverse it. Now, that's not to say that every chemical reaction is irreversible. It's just to say that's a really good way on this type of question to tell if it's a chemical or physical change. All right, so listen, that's our time for today, but we've only covered chapters 2 and 3. So you still have to go over chapter 4 and chapter 5, chapter 6, 7, and 8. So that is a lot. That's 1, 2, 3, 4, 5. 5 more chapters that you need to go over. And listen, that means I'm not going to be able to go over them all with you. So when you come to class on Thursday, or Jordan, when you watch the video later, like you can, never mind, we won't have a video. What I'll do, Jordan, is I'll just have to post the answers on Edmodo. so you can check your work, okay? But
Okay.
as you're going through these questions, I'm going to spend time where you need help. I'm not going to spend time where you don't need help. So make sure you're coming with specific questions. Yes, ma'am.
I just want to remind you to make us able to see our tests on Edmodo.
Great. So when I exit this call, I will go into Edmodo and make it so you can see your test.
Thank you.
No problem. Thank you for the reminder. All right, guys. Have a good day. I'll see you on Thursday, and I'll see you, Jordan, on Wednesday.
Thank
Okay.
you. Bye.
Bye.
Okay. Bye.